Let's look at another example here. We have a total of 65 students that tried out for a football team. The coach must select 20 of the 65 for the team. Is this a binomial experiment? So are the trials identical? Okay, so he's going to have 20 selections here. So it's going to be actually 20 different football players. They're going to be trying out here for different positions. This is really kind of questionable between, whether the trials are identical. I mean, the tryout for the kicker is going to be a lot different than the tryout for the quarterback. So here, maybe not. Certainly a possibility that the trials are not identical. Only two outcomes. Well, either they make the team or they don't. So you could consider two outcomes. So you can consider this as a yes/no outcome. Yes, they make the team, or no, they don't. Is the probability of success the same for the 20 that are selected, or even for the 65 that try out? Is this the same? Probably not. Because those different players are going to have different skills and different abilities, and so the probability of their selection is the probability of their success, which is a yes here, is probably going to be different. And are the trials independent of each other? So if they already find a really good player for one position, is that going to affect their decision later? Yeah, it probably is, So the trial's independent here? Probably not. There's probably going to be an effect of one trial on the next. So I would say here that this is not binomial. Now, sometimes you can tell right away it's not binomial if there's more than two outcomes. Like, if I said pick a color, well, there's definitely more than two colors. So if there's more than two outcomes, it's not binomial. If there are only two outcomes, that doesn't mean it is binomial. You still have to have identical trials, probability the same, and independent trials.